All right, guys, we're going to try something new today. As far as like here, we're going to take a video. Here are the notes for Tuesday's lesson, Tuesday, March 31st. We're going to be graphing logarithms. We're going to deal with this top portion up here. Hopefully I got the camera zoomed in where it needs to be for this section so you can see everything. You should be able to follow along with what we got going on. All right, so we're going to talk about inverses, or we're going to talk about graphing logarithms, but to graph logarithms, we're going to be talking about inverses of graphing exponentials. So what I'm going to do is I'm going to do the exponential thing first, and then we're going to talk about how that changes, okay? So if we look at this exponential function, which is here, all right, which is y equals b raised to the x. If we were to use this going down and we just plugged them in there, so now we have our base is 3, so our b equals 3, and our x's are here. So if I put 3 to the negative 2, that would be 1 over 3 squared, which is 1 over 9. So when x is negative 2, y is negative 1, 9. If we were to plug in negative 1 there, we'd have 3 to the negative 1, which is 1 over 3 to the 1. Remember, we flipped that, so that is 1/3. Then we're going to plug in 0 into that. Anything raised to the 0 is simply 1. 3 raised to the 1 is 3. 3 raised to the 2 is 9. Okay, this was the baseline exponential. It's a growth function because 3 is greater than 1. It's not a fraction. It is not negative, so it doesn't reflect flipped or anything like that. So our asymptote is going to be y equal to 0. So that's our baseline asymptote, which is there. All right. And then we'll plot our points at negative 2. It's like negative 1/9. Da-da-da. 0 is 1, 1 is 3, and 2 is 9. And we're going to have an exponential growth function that looks like that. We did that before we left. We did that. We were supposed to do it last week as well, looking at our domain. Our domain is negative infinity to infinity. And our range is from bottom to top, which is from 0. It's not a bracket, it's a parentheses, all the way to infinity. It doesn't touch. Hopefully we understand that. Hopefully that is something that we can grasp fully, okay? So now we start talking about logarithms. Logarithms, if you remember the whole how to move this, how to change this. So if we had... Remember, if we had b, log of b to the y equals x, right? So if we had this logarithm, and we did this little thing here and this thing here, that meant that it was y equals b raised to the x. We did that. So basically what we're looking at here is exponential functions and logarithmic functions has something that goes in common. We're able to manipulate them back and forth in both directions, but they're graphically going to be different, okay? Technically, a logarithm function is the inverse of an exponential function, of the same exponential function. So that's what we're going to be looking at. So if you don't remember from previously, when we do when we do inverse functions, the first step you would always do is change your y. So let's just do a baseline exponential function, okay? Let's just say it was 3x plus 4, okay? Remember how we would do this to find an inverse? Well, first thing you do is you change f of x to y. Right? Then you change your x and y's places. And then you solve for y. and then that's your inverse, okay? That's pretty much what we're going to be doing today, okay? Where you're going to be changing your x and y, if you will, and that'll be your first step when you change your x and y, their positions, okay? And then you end up solving for y. Very similar, except we're going to be doing it in a logarithm form. In a sense, we're going to be writing it in logarithm form. So if we were to take this initial equation, which is a function, f of x equals y, so you could put f of x equals b raised to the x. So if you were to change that, or change positions, x and y, you would end up with x equals b raised to the y. Okay? That would be your first step. You're changing those positions. That is going to be your first step. So then when you solve for y, you're going to rewrite it in logarithm form. Very similar to what you have here. Very similar to what you have here. Okay? So what you have is you're going to be trading places, or you're going to be doing this in reverse order, if you will. So our base of our exponential function, which is b, is always going to be, I'm going to do it up here so you can hopefully see it, is always going to be our base of our log. And then how the y, just how this, see how you took your b and you raised it to that opposite on the other side, raised to the x? That would be our y. And then our x ends up being our argument. So if we were to do this, we would have x equals b raised to the y. Same thing as we have here. So when we solve for our y, we actually have y equals log base b of argument x. Okay? So, all right, so now we have our exponential function. Now we're going to take our exponential function and we're going to put it in a logarithm function. To do that, we have basically taken the inverse of it, if you will. All right, so if you do or do not remember, like inverse, we go back to this. Our inverse of this, if we were to graph this as an inverse, so this would be y-intercept of 4, right? And then it'd be a graph of 2. It'd be a slope of positive 3, which is like that. Okay? That's what somewhat of what this would look like. Okay? So when you do an inverse, whatever you take an inverse, when you take an inverse, you're reflecting over y equals x. So this is y equals x. Right through there is y equal to x. So we're basically going to end up flipping that over that y equal to x. So if we were to take this, we would have a slope which would be like which would be, let me see, it'd be negative 1 1/3, which is here. And this is 1 over 3. 1, 2, 3. 1, 2, 3. It would end up looking something like that, which is basically taking this original one with the arrows and folding it over this line, and it would look like this function, or this line would be this function. So that would be the inverse of it. It's a little bit harder to see when they're linear functions, but we've done this. We have done this. Whether you remember doing it or not, we have done this, okay? So now if we go back to this, if you think about, you look at this graph here, if we were to flip this over basically this line, if you will, you can see that the function's probably going to look like this. Instead of it being a U like here, it's going to be kind of an upside down U. All right? So let's plug in some points and let's think about what we got going on here, okay? One thing you have to remember is because we traded places with X and Y, basically, if you think about it in these terms, the same thing's going to account for our X's and our Y's. Okay, so how this here is your baseline point, okay? That baseline point of 0 and 1, you can obviously say that your baseline of 1 is going to be 0. Trading places. Let me do this arrow to here. Okay. Trading places. All right, so this would be 1. I'm going to erase this thing here because this is just a little bit off. This would be 1, 0, which is a point which is right there. Okay, so if we have that point as 1, 0, they're basically flip places. So if I plugged in 1 here for my X, if you will, if I plugged in 1 here for my X, all right, what would Y have to be 1? Okay, so you're looking at this thing is, if you looked at this right here, this could be rewritten as 3 to the Y equals X. Okay, 3 to the Y equals X. 3 to the Y, because we're doing this, right? Equals X. 3 to the Y equals X. So if I plugged in 1 here, what would my Y have to be for it to be equal to 1? Well, 3 raised to the 0 equals my 1 or my X. Okay, that's always going to be your baseline. Since your baseline for exponential was 0, 1, your baseline for logarithm is 1, 0. Okay. All right, there's a few things you got to remember about logs. Number 1, you can't have negative numbers. You can't have an argument of a negative number. So your X, this argument here, can't be negative. Okay, so we want to basically start it as our 1. Okay. What would be another good number that you could have? What would be another good number that you could have? Well, you could basically follow suit and do all of these the same way if you thought about it, okay? Since this flipped this way, then you would have, when your X was 3, your Y would be equal to 1. So if I put in here, I put log of base 3 to the 3 argument, well, that's always going to be equal to 1. So we have 1, 2, 3, and 1. And we'll follow suit and do 2 of 9. 2 of 9. Well, we'll have 9 of 2. Apologies. I forgot to flip them. 9 and 2. So now I have 9 and 2. Now, we have it going like this, okay? But we can use these two down here while my Y can't be, my X can't be negative. My X's can be 1/3 and -1. So I have 1/3 and -1 and 1/9 and -2. So it would end up looking like that, okay, on your sheet of paper. All right, so what this happens now is while we have an asymptote for our exponential of Y equal to 1, now our asymptote for our logarithm will be, Y equal to 0 will be X equal to 0. So now our asymptote is a vertical asymptote. This is a vertical asymptote, where this one is a horizontal asymptote. A little bit different, okay? Also, how everything is flipping, if you will. Everything's flipping. So now our domain is from -infinity to +infinity for our exponential, because it's going to follow suit. Now our range will be from negative infinity to infinity. And our domain will be from 0 to infinity. All these things are flipping because it's based upon exponential and logarithm being inverses, and your x's and y's flip. It's going to take a little bit of practice, going to take a little bit of time, but that is the first problem of the notes.